So in the last video, we took our logistic model and we said, what happens if we add hunting? How does that change it? And we saw that it really doesn't change the model, right? It just kind of pushes it down. There isn't a significant change in the model until you get to that maximum sustainable yield, where you switch from having growth to having always negative growth, okay? So what if instead of hunting a fixed number each year, you hunted a fixed percentage, okay? So say rather than killing H every year, you killed H, let me use green, H times X. So H is some percentage of the model. So like H here might be like 0.02, and we apply that to X. So as the population gets smaller, we hunt less and less of a percentage. What does that get us as a model, right? So H here is percentage hunted each year. Okay? So we can analyze this in the same way. If we had actual numbers, we could just go ahead and graph this. Since we don't, we're going to need to be a little bit more careful in how we do this. But we can actually look at this equation and figure out what it looks like just from what we've got here. So if you look at this, this is dxdt is equal to, we can pull an x out of all of these terms, right? So if we pull an x out of every term, we've got negative r over k x plus r plus h. Okay? And so what this gives you is your equilibrium points. So you've got an equilibrium at x equals 0. You've got an equilibrium where this is equal to 0. So at negative r over k x plus r plus h. So negative r over k x equals negative r minus h. So x equals k minus, what do we get here? H times, oh no, k plus h times k over r. Okay? And so if you look at this equation, unlike what we had before, well, actually, exactly like what we had before, we have a parabola here, right? This is a parabola. It faces down. It's going to cross the x-axis at 0 and at k plus hk, or I'm sorry, I'm going back to my model. I wrote a plus sign up here. We're hunting a fixed percentage. So we're not adding in h times x. We're subtracting h times x. So this is a minus sign here. This is a minus sign here. Plus sign, and this is a minus. So that makes more sense now. So what we've done is, if you look at this graph, it goes from 0. We have a parabola that goes up until we get to this k minus hk over r. What we've done is we've just reduced the upper equilibrium. Okay? So the upper equilibrium, the carrying capacity, has just gone down by hk over r. Okay? And so this is an interesting thing. If you think about what happened when we hunted a fixed amount, so hunting H every year, that gave us a model that looked like this, right? So when we are hunting H every year, we now had this minimum viable population. If we dropped below that viable population, the whole population would collapse, okay? If we hunt a fixed percentage every year, that doesn't happen. Our model is still fundamentally the same as our logistic model. We've just changed the carrying capacity. Okay? And so phase analysis can show you these kinds of things. what the differences are between changing a model in one way versus changing a model in another way. And you can see kind of fundamental differences in the model. Okay? In our next video, we're going to talk about non-homogeneous equations where we depend on x and t.